Hello boys and girls, and welcome to another episode of FoulkesBrau. Today we're back on the bench with the gift that keeps giving. So in the previous videos we fixed the treadmill motor drive board, and that's now in and seems to be working. But when we switch it on, the control panel, the buttons and all the displays and whatever, only show LCD segments, in other words, those little lines and stuff. And so anyway, we open it up, and yes, let's just say it was very messy. So I've brought it here and we will have a look together. In other news, this not being a political channel, but it is interesting to note in South Africa, all of a sudden, I don't know how many of our politicians, I've lost count. This morning I heard on the news that there's another one that is now being implicated in the PPE scandal, personal protective equipment scandal. Now, for those of you not aware, we got a gift of 500 billion rand or whatever the hell it was from somebody. And then we got $5 billion or $50 billion from the IMF. And part of that, the conditions for that was that it would go on healthcare and whatever. But our politicians seem to have formed all these companies, funny enough, in last year, November, specialized PPE distributors. Now, either they knew something was coming, I don't know, call me conspiracy theorist, or they've backdated, or something nefarious is going on. But either way, solely left, right and center, they are being implicated and getting caught up with this. We now have the government-appointed SIU, the Special Investigations Unit, to investigate fraud and corruption and I don't know, whatever. But what I don't understand is the ruling party, the ANC, says that they will investigate the corruption within. And to me, that's a bit like let's appoint criminals to investigate criminals, or let's appoint a thief to investigate a thief. Maybe there is some logic in that. I'm not sure. Either way, like I said, this is not a political channel. We're still not allowed to buy booze. We're still not allowed to buy cigarettes because it's not good for us. So I'm still smoking this cheap rubbish that we buy. Well, in normal times it's cheap. Nowadays it's going for roughly 3 to 4 times the packet of what a normal legal cigarette would cost you. And I'm getting to the end of my tether with this because, yes, I'm a die-hard smoker, and I don't believe that anybody should tell me whether I can smoke or not. It's my choice, but even now it's becoming ridiculous. But I will hold on in solidarity to smoke with the guys, and even if I have to pay through my nose, and I will not be forced to quit because some chick in a dook says I must. Beer, well, alcohol you can't buy legally. It is killing the restaurant game and the alcohol retailers. It really is bad for them. Heineken has pulled out a whole bunch of investment plants that they were going to build. AB InBev has jumped on the bandwagon and said they're not going to waste money on capex, capital expenditure, in other words, build new plants. The thing that is scary and that a lot of South Africans don't realize, or craft beer drinkers, is that there are a lot of craft beer brands in South Africa that actually fall under the Heineken umbrella. Soweto Gold is one. They were bought a few months, well, my time is a bit rubbish, but say, I think it was about 2 years ago, they were bought outright by Heineken. There are also other breweries that have distribution agreements in place with Heineken. So, the knock-on is terrible. Anyway, enough rambling. Let's get on the bench and let's have a look at our problem today. So here is the front control panel that we took out the board, and we can see there's just a basic board with some caps. And obviously this is the back end of the board, a speaker, and funny little looking board which we'll have a look in a bit more detail in a bit. Some speakers, and I've just taken the screws out to make it easier. If we lift it out, we can see is our 7-segment LED displays with a whole bunch of LEDs for obviously all the different programs and you know, how would I call it, your actual parameters, like maybe, I don't know what this treadmill particularly would show, but say now you've set it that you want to do X amount of let's say meters per second. It's way too fast for a runner, but anyway, now I'm sure it will give you some sort of feedback and whatever program that you are on, and some sort of estimated calories burnt or kilojoules or whatever energy expenditure. But really there's not much to it. Some 74 series logic in here, inductors, nice inductors up there for noise, some voltage regulators, more capacitors, optocouplers, and some sort of microcontroller here for the different programs, I take it, and again some more logic. So there's really not much to it. Down in there, that little IC down there looks like a, what is it, a LM 329. So dual op-amp, dual comparator. So really not much on this board, but like I say, when you power it on, what you do is you just get the vertical stripes of each LED segment powering up, and that's why we took this board out, because when we did take it out, what we noticed, let's see if we can get a better shot for you, is this little board here. So I'm going to just take the autofocus off. We'll zoom in as much as we can and have a look at that. If I can hold it. What you can see on the right hand side of it, over here, there are a whole bunch of chips missing. It's corroded in its looks. I mean, you can see the corrosion up there on that IC, that inductor. Look at that, corroded, corroded, corroded. Now what I do know from measuring on this board, we have a ground, the black wire, and we have a 5 volt coming in, and we have the white wire going out. Now what is this board? Well, it's a bit of a giveaway. We have capacitors, we have a common mode choke, we have some ICs in there, another IC down there that's corroded and it's modern, a big inductor down here, and some capacitors, and it looks like some resistors and stuff that were there. Now to go and reverse engineer this and figure out what it was and to try and mess around is going to be, well, it's not impossible, it's very easy to do, but we don't know what it's doing. So the first things first is we need to find out where in the circuit this white wire goes. What is it actually doing? And then we can pick a strategy. Either we fix this board, this little switching board, or we build a new one. If I look at this board, I'm going to guess that it is I'm going to guess that this is a step up converter, a boost converter. Simply put, we have 5 volts coming in. Depending where this is going, I haven't seen any 12 volts on this board, so I'm going to guess it might be a 12 volt little switcher. Anyway, let me take this, let me clean it, and we'll have a better look at it. I'm just going to brush it down with some IPA, isopropyl alcohol, and we will come back to it. Alright, I've given our board a little bit of a clean with some IPA, and we can see quite a bit of corrosion. You can even see some of the pads are gone. So that is going to be well, put it like this, it's not unrepairable, but for a little switcher it's really not worth the headache of repairing traces and trying to dick around there. But we can see quite a bit of a corrosion. Interestingly enough, I just cut off at the back. They've to try and insulate the bottom, they've put this very hard sponge rubbish on. I don't know why they do that. You know, put the board on a standoff, or even better, just put in a bit of heat shrink. But clearly they didn't want you to work on it. It still doesn't give us much clue yet of what this is, if it's a step up or a step down or inverting. It might be inverting, but I doubt it. I think more likely than not it's a step up. A nice big capacitors. I mean, if we look at the capacitor values, 16 volts. We've got 5 coming in, we've got 16, 16, 16. Common mode choke for noise. Inductor. These are obviously some form of switching chips, and probably our MOSFET in IC. So probably a switching chip, MOSFET driver, MOSFET. Over here would have been some sort of resistor divider feedback into that, or one of these chips, whichever one's doing the switching, so that you can control the output voltage. Really not much to it, but we might want to use that inductor depending. On the back end, not much there. Capacitors up there. So yeah, really not much to it. So let's find where this, well, we know where it's coming from. Let's find where it was going to. So let me take the other board out and we'll have a look at that. Right, so we've taken the board out. What I've done is I've put my multimeter into continuity mode. I've put a little grabber on the negative there. Not the negative, the white wire that we said is coming back. So if I short that, I can see it's continuous. So now we're going to follow the track. If you won't be able to see nicely. Okay, it goes there to these little wires, and it comes all the way under here, under this chip over here. So if we go and we probe that chip, there we go. So it's coming to that pin over there. Is it going anywhere else? Doesn't look like it. It's only to there. There's some wires down here. Another thing you can do is just take your probe, if you've got it sharp enough, and lightly rub it over the legs of the chips that you suspect. But in our case it looks like it's only coming to our microcontroller. So now we need to find out what the heck that is. Okay, so it's got index DKA6TG01, index Delta Kilo Alpha 6 Tango Golf 01 is the label. So I'm sure that is the revision of the software. Now what on earth can that thing need? Oh, we need to find out what it is first. So we take the label off the chip. It's actually quite easy. I'm just going to put a bit of alcohol on it and I'm going to lift it off with a scalpel. So let me do that and then we'll come back. Okay, we've taken off our label to identify our IC. It is a Winbond W78E65. That's Whiskey 7 Echo, Whiskey 78 Echo 65. A 40 Papa Lima. It's an 8-bit microcontroller based on the 8050 processor. And if I go and I look what that pin on our package, specifically this PLCC package, that pin is pin number 17. It's port 3.5, which is IO port 3, and it's the same functionality as the standard 8052. So in other words, it can be input, output, etc. If I go further into the data sheet, so this chip is supplied with 5 volts. They talk about the high and low limit on that chip because it can't be an output. That's for sure. It's got to be an input, but they talk about it being, where are those min-max values? The high voltage, they talk about maximum 5.5 volts, and the low state being less than 0.8. So the only way we could figure out our little switching regulator is, let me put bench power on this board. We'll see what's going in, and we know whatever's going in, this pin should not be higher than 5.5 volts. We can make it 5 volts or whatever. So yeah, that could be the case. Maybe they've got a 5.5, 5.6, and they're using, because you can't use a linear regulator because you don't have enough headroom. That might be it. But let's power the board and let's get it hooked up and let's see what have we got going in on the red and black. Then we can see what we should have out on the white. let me set that up. Right, so we're back. I've just hooked my bench power supply to these bulk storage capacitors. I've set it to 12 volt and limited the current to 200 milliamps. So let's turn this around. So that you can see what I'm going to see. Just move those lines out the way. So if I switch it on, we hear the beep, and there you see typically what I see. All these segments that have lit up. So let us now measure you're going to have to take my word for this. I'm going to measure voltage. We zoom out a bit. No, I can't. Okay, so you're going to have to take my word for this. So what I'm going to measure up here is between the ground and the red pin. I'm getting spot on 5 volts. If I measure between the ground and the white pin, .0, it's fluctuating. It doesn't make sense. I'm just measuring that pin on the chip now, 0.013. Could it be that that chip is an output? Why would they have a switcher? We've got 5 volts in, clean. Anyway, that's what it displays. Out of curiosity, this 2-wire out here, where does it go? Up here. This is the safety reed switch, so I'm just going to short it out. That's basically that magnet thing that you plug around your wrist and whatever. So if I short that, that should simulate that the board or that the treadmill is healthy and you're ready to do whatever. Strange. There, I've shorted it. No. It's a bit difficult to hold it here. So let's do it like this. I'll take one of these grabbers. Excuse me. These bloody cheap cigarettes are really hell on the chest. Okay, we'll short it like that. Let me try and stand in the sun and block the light out. Okay, the level 3. So it did something. And then we've got the 1 on, the level 3. Let me just try and blank out the light here a bit for you. Maybe you can see it a bit better. And we'll go through that again. So there is what we see, all dead. Then we go through startup, zeros, some OL flashing, DH, and then it switches over. So that tells me that this microprocessor is working. Interesting. So sorry for bumping you there. Let's measure now that it's in this state. We've definitely got our 5 volts in, nice regulated. And that'll be from this regulator down here, LM7805. That's our ground. Output perfect, input 12 volts, regulated like a baby. 5.019 volts to be exact. So I am really confused as to what that port is. Unless, no man, it can't be. You have a switch on it. No, definitely can't. No, I'm confused. I have no idea what that port does. So I'm really that curious about it. I'll have to see if I can get my hands on the code for this and go through the code and work out what it's doing. But I'm really not that curious. What is interesting is that the processor appears to be firing up. So obviously we're driving all the different logic gates and whatever. Otherwise we wouldn't get to these stages. I can of course go put the scope on it and look at the different telegrams, but I don't suspect a problem there. I think that this is working fine. What I am thinking is that my mate's cable to his reed switch is gone. But that's not a train smash. We'll restart it again. Yeah, all zeros, DHOL, and then L3. So I'm really convinced that this is working. Let's see, are there buttons there? I can press buttons. I don't know what I'm pressing. But I'm pressing it. So let's see. Obviously I don't expect anything to do anything because I don't have anything connected to it, but yeah. So I don't know. I'm wondering if, let's have just another measure there for my own sanity. Our input voltage is fine. Funny, when I start it's 0.2 and then it drops. I wonder when that switcher went if it didn't damage the port on this microcontroller, in which case we got a bigger headache. Let's see if I put a scope on it. Just get a probe. Let us have a look. Maybe our probe won't load, our scope won't load it down. You're not going to see this yet, so if there's anything interesting I will show you. Let's just switch the output off. I don't want to short anything out with me hooking in here. Yeah, that's fine like that. Let's see if I see anything. No, I do not see anything. Just noise. I see anything up here. There's the clock. So definitely got a clock. It's driving something. Some sort of telegram nonsense. Yeah. Clock. Data lines. And our problem child. Data and pulses. I'm just probing randomly on different chips, different pins, just to see if there's any life on the thing, and yes there is. I can see telegrams, well I can see data, and I can see the clock and IO switching and doing its thing. So I'm presuming the processor is working. What I don't understand is what that thing is doing. Let's have a look at the clock. Off. We switch it on. Yeah, no, it starts up and does its thing. And that port, nothing. So, that's me that shorted it. Ladies and gentlemen, I really don't know what that port does, but it doesn't seem to be important to what we're doing. So I'm going to leave this one there, where it is. What I'm going to do is I'm going to take it and I'm going to put the board back into the machine. What I suspect that my friend has done, or I don't suspect, he's done, if I look at the corrosion, I'm suspecting that it took that switcher out, and when that switcher went, depending what it is, if it's a step up, which doesn't make sense because the ports are limited to 5 volts, but if it is, then but it doesn't make sense either, because you've got 5 volts in, it's clean. Why didn't you just take that right through? But if it was a step up, you don't have isolation because your switch would be switching to ground, so your input voltage would pass straight through. The only switcher that I can think of the top of my head where you would have some isolation between input and output is the step down, where your switch is in series with the circuit. So I am confused. I'm stumped. So what I'm going to do is I'm going to take this board in. I'm going to take it back to my mate. I'll go and put it in, and we'll power it up and we'll see. And then what I'll do is like this. We'll check his reed switch for the magnet through, because I suspect that's where his problem is lying now. It's not here. And we'll see if it powers up, if we can drive the board. If not, if this port on this MCU is important, which it must be, if you wouldn't just put it there for fun. But if it is, what we'll do is we're going to see if we can get a replacement MCU, because maybe, just maybe, when that switcher went, it's damaged that little port, which is going to be painful. We'll see if we can get a replacement, and we'll see if we can get the firmware for it. If we can't get either, then we are slightly stuffed. Then we'll have to get a replacement board. So I'm going to leave it there. We'll set up for the closing shot. And so we come to the end of another episode of FoulkesBrau. Very, very interesting. Do we have a damaged port on the MCU, or is it just some random arbitrary stuff in it? I don't know. I've never looked inside a treadmill. I have my own personal treadmill. Maybe I will have a look at it. So it's same company, just not same model. Maybe that will give me a clue. Very, very strange. I can't imagine what they're doing there. But anyway, yeah. So we've come to the end of another one. I suspect, again, it's not particularly this board. I suspect it might be the cable now between this board and where the reed switch plugs in. I think that might be a bit damaged. It's easy enough to sort out that we can do. Very interesting, strange little fault. Obviously, if we can't get a replacement MCU, or we can't get our hands on the firmware, that's the end of this repair. We can't go any much further. Anyway, this is a strange thing. I don't know what to say. As always, I hope you had fun. I had fun. Take care, be safe, and we'll catch you in the next one. Cheers.